Hello everybody and welcome to Pisa Presents. Today we are going to be covering one that is very near and dear to my heart, the one and only Dimetrodon. Now, one of the most famous and popular, of course, prehistoric animals is the genus Dimetrodon. Now, Dimetrodon is not really one, but many species, a group called a genus. Dimetrodon's name is a reference to its two rows of specialized teeth. They're actually amongst the earliest animals to even have serrated teeth. Its various specialized teeth may have been an adaptation to deal with various kinds of prey, or perhaps the specialization even helped its dental health in a way. They think that maybe having these different kinds of special teeth lessened physical stress on a particular tooth that wasn't styled to handle that particular stress by, another tooth being able to do so. Now, long mistaken for dinosaurs, Dimetrodon species are anything but. They actually are not even really that closely related to dinosaurs and went extinct roughly 40 million years before the dinosaurs themselves even appeared. So let us look at what a Dimetrodon really is with the help of our guide here, Dennis. Now, or at least a facsimile of Dennis. Many years ago, the very first person to tell me of these wonderful creatures was actually my Sunday school teacher, whom presented me with a tiny red toy very much like this one. I still have it. It is in a precious place up in my attic, which I would have taken it down and taken an actual picture, but there's no way I'm going to open up my attic to our cats. I would never ever get them out of it. So, in her honor, let us examine the wide and wonderful world of the one and only Dimetrodons. First, we'll take a look into when these creatures lived, then what are they really? So, what are they and how did they evolve? Also, too, I'll look into their fossils and how that gives us clues into their habitat and habits and size. Also, as well, you cannot obviously take a look into the Dimetrodon without looking into an analysis of their most famous feature, their sail. Now, the last most common ancestor of all mammals and reptiles, whatever they were, lived about 310 million years ago. Its combined lineage then split into, basically, generally speaking, two different groups. The synapsids, which included eventually not only all mammals but also their nearest relatives, which includes, as things turns out, the Dimetrodon. And the next group is the sauropsids, which includes today's living reptiles and also several extinct reptiles. That would also, yes, include the dinosaurs. Now, Dimetrodons, being synapsids, they are creatures with mammalian and reptilian traits. So that makes them members of the sister family to our own ancestors. So they're not our ancestors, ourselves, but really think of a Dimetrodon as your great aunt. Well, really, really great aunt. Now, you may see a lot of arguing over outdated terminology when it comes to Dimetrodons. People can term them as, say, pelycosaurs, mammal-like reptiles, or names given to groupings with them. And for years, Dimetrodons and other synaptids were called proto-reptiles or other classifications. Now, a lot of these names get thrown back and forth, but really stem mammals, proto-mammals, and some other names are the best ones that are used right now, but you'll see stem mammal used probably the most a lot nowadays in the literature. Now, this is why Dimetrodon cannot be classified as a dinosaur, despite the efforts of many that still try to call it as such today. They're too divergent as creatures. Not only are you dealing with several million years of evolution just splitting you apart, but they are synapsids, whereas dinosaurs, being reptiles on the opposite sides of the family tree, are sauropsids. Dimetrodons are more closely related to us, humans, than they are dinosaurs. And while the number of their species fluctuates, yep, see, there they are right there. Oops, nope, wrong one. So off he goes. Now, while the number of their species fluctuates, there are about a lucky 13 species of Dimetrodon, all of course extinct today. But when did they live? Well, in order to find that out, let's begin our story in the wetlands of what becomes North America during the Permian period. Now, that's up there in the upper left. You can kind of look to see roughly what the continents looked at with their layout during that time. So, from about 295 to 272 million years, the Dimetrodons were amongst the top predators of their ecosystems and actually were the largest terrestrial vertebrates of their time. How they lived is kind of up to debate, but they were most certainly terrestrial animals with a taste for various meats. They were carnivores, and they did indeed like seafood. Now, so they could have easily found themselves at home hunted in shallow water as well as land. So they were wetland dwelling animals. Now, contrary to myth, while he did name them, Edward Drinker Cope did not discover the Dimetrodon. That honor belongs to Donald MacLeod. And I'm sorry, but every time I see that, that's just a guy whose name makes him sound really more than passably like a Highlander. It just, I mean, that name just really just screams Highlander right there. Now, his own specimen is this one right here. It's a mandible. It was found in 1845 on Prince Edward Island in Canada. So, yes, as in like the Anna Green Gables and Avonlea books. And it was actually misclassified until 2015, which is why you may still find him not getting credit in a lot of older books and sources, simply because people didn't really know that this guy was the first one to find what we now know is a Dimetrodon fossil. Now, these fossils themselves can also be found in various other North American states, well, like Texas as an example, or various other North American locations, rather. Like Texas is one state, Ohio is another one, also too Germany. Now, Cope did his own studies from the area of Texas, what is called the red beds. And while he did indeed name the genus first in 1878, he did describe it under a different name earlier the year prior. Okay, so not all illustrations are created equal when it comes to paleo art. And Dimetrodon tails contain about 50 vertebrae, and they're about a good portion of their length, a fairly fair portion. But you have to keep in mind that we didn't find a specimen with a decent amount of their tail to them until 1927. So for some years, we got some rather, well, fanciful reconstructions here. But we're just not talking about really paleo art. This brings up a very, very good kind of point when it comes to reconstructing an extinct animal. So when you're missing something as crucial as the tail, if you think about it, that really knocks out a huge part of the organism. So not having the tail, that not only kind of takes out a lot of things. That affects paleontologists reasoning out how the creatures not only move, but also effectively how they hunt. And for years, it simply didn't make sense to a lot of people that one could have such a large potential animal, potentially speaking. There were very small Dimetrodons too, with a very small tail. And it wasn't until they started finding more and more tail components to them that they were like, oh, this makes sense now. And they were finding trackways too that started to make a little bit more sense about how they walked and how they moved. Now, how they move still is up to a bit debate. Now, we have these footprints and trackways which suggest that Dimetrodons moved in a manner akin to modern-day crocodiles or, say, monitor lizards. Now, there are a very few people that argue against that, saying that Dimetrodons were too mammalian in their traits for this, and that it wasn't efficient enough, and that the animals carried themselves higher, like more like a modern day mammal. but overwhelmingly, the evidence is in favor of them having a crocodilian sort of like a, for lack of a better term, speed waddle, if you can just picture how a crocodile moves. And yes, they would still be living in the wetlands. I waited over 30 years, 30 years, mind you, plus, for a Dimetrodon in a Jurassic Park movie, and I got them in a bloody cave. Still kind of mad about that, I will admit. So, sorry folks, but these creatures were not cave dwellers. Their food sources were out in the open and along the shore, not, poof, within a cave habitat. Now, going back to this image, it gives you an idea of the range of sizes that they could have. The smallest Dimetrodon was a mere 24 inches long. I mean, come on, just 24 inches. That's incredible when you compare that to the other ones. Now, not saying, I mean, just to throw that out there into the ether, not saying that for that I'd risk going like full-on John Hammond if I could safely pull off having a 2-foot pet Dimetrodon, but if just again in theory I could, well, somebody get me a DeLorean. Now contrast that to, two of your larger ones, Dimetrodon angelensis, which could have been about 13 to 15, some people say 16 foot long and 550 pounds. And then Dimetrodon grandis, which was a little bit, not as long, but was even bulkier, stockier at over 550 pounds. I mean, these were very, very large, potentially, animals. These things were huge, depending on the specimen. Now, their skulls are much longer, famously, than they are wide, with the eyes positioned far back behind. Now, behind each eye opening is a large opening called the infratemporal fenestra. This is typical of synapsids. And in the back, the very back of each skull, there are actually openings on either side, which is not typical of early synapsids and is more in kind with mammals. Now, what is the function of the sail? Really, we don't know. Firstly, it's a bony structure made of what are called neural spines, the actual spines themselves. Now, for many years, paleontologists theorized that the sail absorbed heat and had some sort of thermoregulatory capability. But that's been fairly well debunked thanks to research in bulk as recently as 2010. Frankly, the sail grew in such a way that it really would have been an ineffective solar panel, so perhaps it had. They think more realistically, although of course this is all really speculative, granted how long ago these animals lived, it would have had a more communicative function in, say, attracting mates or even just impressing the neighbors, basically showing off to other Dimetrodons themselves. And sadly, few good things last forever, and despite their dominance, the reign of the Dimetrodon came to an end with what is called Olson's extinction. In short, ye old reliable climate change did 'em in. Now, how that came about is very debated, but in the end, it was an event that served as a pulse to the even bigger great dying of the end Permian mass extinction. Their precious wetlands dried up, and with it went their food sources, and they simply couldn't adapt fast enough. So, thank you for joining us today, and fear not. While they are no longer with us themselves today, Dimetrodon's closest relatives are alive and well in the form of the diversity that is within mammals themselves. And in honor of the Dimetrodon and other synapsids, that is indeed a thing to celebrate. So, thank you very much, folks, and have a lovely weekend now. Bye!